Number 15, again, expanded form. We're asked to write it in factored form. So I have our method list here, GCF, difference of squares, and trinomials. Always check for GCF first. Is there a number that divides 8 and 32? In fact, there is, 8. And do they share any variables in common? No. So we're just going to pull out an 8 to begin with. So far we did use GCF method 1. So if I pull out an 8, 8 times what gets me back to 8x squared? Well, x squared, bring down the minus sign, and 8 times what gets me back to 32? Well, 8 times 4. I told you to always check what's left in the parentheses to see if it still can be factored any further. So ignoring the 8, if I just gave you x squared minus 4, is there any other method I can use to continue to factor that? Well, because it only has 2 terms, the only option would be method 2, difference of squares. So let's check. It's definitely a subtraction sign between them. Is x squared a square? Yeah, because x times x gets me x squared. And is 4 a square? Yes, because 2 times 2 is 4. So we can actually factor this as the difference of squares. So the 8 is still in the very front. Difference of squares, you always open up 2 binomials. You alternate the signs, one's a plus, one's a minus. And the first term, which was x squared, gets split up in the first spots. X squared splits as x times x. And then 4, the back term, gets split up in the back spots. We said it was 2 times 2. This is completely factored. And you're almost done. Don't give up. Keep going. Last 2 questions.